All right. I think in the interest of time, we'll go ahead and get started. We are recording the call, so people who either join late or aren't able to join at all are going to be able to listen in. My name is Mitchell Warren, and I direct AVAC, and delighted to welcome you all here to this webinar. I'm going to spend just a few minutes providing some logistics updates. I'll take us through the agenda for the call and give you a sense of how to engage in the conversation, and then turn it over to some presentations, and then we'll have a discussion. I really want to thank everyone for joining. We have a huge crowd on the line, and we're grateful for that. I know this is a topic of enormous interest, and over many years of doing PrEP-related webinars. Very excited, in fact, as challenging as each topic is, it is incredibly exciting to be talking together about what we all need to be doing and thinking and knowing, and as oral PrEP enters into implementation activities in a number of countries around the world. And I think we've said on probably every call in over a decade around PrEP that nothing about PrEP is ever easy, and this topic is no different. You all are on the call because you will have seen notices and emails about conversations on a range of listservs, and really want to give a huge shout out to Jim Pickett and the IRMA community for really engaging in the conversation, along with a number of PrEP related listservs that brought you all here. But just to give you a quick sense of the run of the show for today, over the last couple of weeks, there's been a lot of conversations about what we do and don't know, and what we do and don't think or believe with respect to the time to protection for oral PrEP. And this has been a conversation that has gone back a number of years, and certainly beginning even in 2010 with the iPrex results, the first PrEP trial to demonstrate safety and efficacy, trying to understand how long one would need to be on PrEP to gain protection. As many people will know, the first approval in 2012 from the FDA happened, and very quickly thereafter the U.S. Centers for Disease Control and Prevention provided their initial recommendations. And they focused on, in terms of time to protection, what was known at the time based on a range of different scientific methods that you'll hear about on this call, a sense that perhaps people at risk from anal intercourse would get protection perhaps within 7 days, but vaginal protection may take as much as 20 days. And that is very much in the CDC guideline, and it's been used in a number of programmatic settings. At the same time, as I think everybody on the call will know, last year in June 2016, the World Health Organization provided a very broad and encouraging recommendation around oral PrEP for all people at substantial risk as part of the comprehensive antiretroviral guidelines for treatment and prevention. And you'll hear, and many of you will know, there are implementation guidelines to help programs that have been in draft for many months and are being used in a number of countries to help convey support to how to roll out PrEP programs. In the midst of that, as many people will know, the World Health Organization recommendation from back in June does describe the time to protection as 7 days, and that's irrespective of mode of transmission. And that has not been widely discussed in terms of how these two recommendations coexist. What's exciting and interesting is that the pharmacologists you're about to hear from have all been involved in supporting data generation and interpretation in both of those guidelines. And so we really wanted to organize this webinar first and foremost to provide background to how this information is generated, the pharmacokinetic, pharmacodynamic data, how it's generated, how it's interpreted, and how it might be used. And very happily, the three people you're going to hear from, Craig Hendricks, Pete Anderson, and Mackenzie Cottrell, have all been involved in working with both CDC and WHO in thinking through the guideline. We're going to turn to all three of them to provide very brief overviews of data that they have been involved in generating, and providing some background to how that all occurs. And then we'll open it up for conversations and discussion. I know also we have representatives from Gilead Sciences on the line, of course, the company that developed and manufactures TDF-FTC is Truvada, who also have a lot of information and awareness of this information. And then, as I say, WHO and CDC have both provided past recommendations, and we want to understand how they're interpreted and acted upon. Given the large number of people on the call and a lot of information that we're going to get from the three pharmacologists. The idea is to really focus on that data now. WHO is on the line, hopefully, to hear all of this, and we are likely going to need to organize a second webinar, probably right after next week's retrovirus conference, to continue this conversation, to really get even more input in terms of what the recommendations and guidelines are. But we didn't want to delay in getting this information out there and get the conversation going. So that is a very brief overview. I will say, as I think you all know, the call is muted so that we can record the call, but we don't want to mute anybody's voice, in fact. So there are going to be multiple ways to engage. Throughout the presentations, feel free to post questions in the chat box if you're on the ReadyTalk interface. If you want to use old-fashioned email, you can do avac@avac.org, and we'll put the questions in the queue. And then once we're through the presentations, I'll give instructions again about muting and unmuting. It'll be *7 to unmute and *6 to mute, so that we can get people to raise questions and comments in real time. So that is the run of the show. I hope that's clear. And as I say, this is not undoubtedly going to answer all questions. Hopefully it's going to raise many and provide us all a sense of where we go forward together. So with that, I'm going to go ahead and start turning it over to Craig Hendricks, who's at Johns Hopkins University. And I think many of you will know these three names that you're seeing on the screen: Pete Anderson at University of Colorado, Mackenzie Cottrell at UNC, who's worked very closely with Angela Kashuba, who many of you will know, and Craig Hendricks, again from Johns Hopkins. All of the four of them have been deeply involved in this work and happily agreed to collaborate on the development of a single slide deck to keep this quite clear in terms of our way forward. But we're going to start with Craig, and he'll in turn hand it off to Pete and then Mackenzie, and then we'll open it up for questions and comments. So with that, let me turn it over to you, Craig. And Craig, *7 to unmute your line.
Okay, can everyone hear me now?
There you are.
Great,
Perfect.
thanks. So the focus on this is time to protection, and in the specific population of women taking oral TDF-FTC. And I will say right at the start, at least for my comments, that the data is so much richer, at least of stuff we've generated for TDF relative to FTC. And I don't mean to leave FTC out, but there are contrasts we can make to it because a fair bit is known, but certainly not as much, at least in my mind, as there is about TDF and tenofovir. Next slide, please. So just a little bit of background before we launch into the three investigator perspectives. I think everyone, and I'm starting with some things I think all the presenters would probably agree with. No study has directly assessed the time to clinical protection. It would require much larger studies than have already been done, and it just hasn't been done. So what we're left with is making some rational assumptions based on pharmacologic principles and then applying some models. And you'll see models of different levels of complexity. Mine are very simple, and Mackenzie, probably of the three of us, may have done the most intense modeling. And I want to make the point that time to protection is not necessarily the same as the time to steady state, and I'll go through why that's the case. I think you'll see data on anatomic compartment pharmacokinetics and see that it varies widely across compartments. And therefore, the protective doses may also likely vary with the anatomic HIV risk. So if one's primary risk is receptive anal intercourse, certain doses are likely protective, whereas if one's primary risk is receptive vaginal intercourse, different doses are probably required. You'll see that kind of data as well. And I also want to add that I think the site of PrEP drug action is not entirely settled. I think there's some suggestions, but I don't think it's entirely settled that it's just vaginal tissue or just colon tissue independent of systemic levels as well. So that's complex. I'm not sure how much we're going to get into that, but this is important, I think, by way of background. So we'll go into my perspective then first. Next slide. So this is just a little bit of concentration time principles. You have a graph here with log of drug concentration on the y-axis and time on the x. And you see the red line, which shows each individual dose. Now this is not specifically any of the drugs we're talking about, just an example to get this sort of everyone on common footing. If you see that it goes up in red and then it comes down, and each of those green lines is if we could look at the concentration from any given dose, we could watch the decay from each of those doses sort of fall off. But because there's drug left over with the second dose and then even more drug left over at the time of the third dose, you get this continued accumulation. But it stops accumulating at some point, and you see that the peak concentration that I've designated Cmax SS, which is peak concentration steady state, and Cmin, trough concentration steady state, that's when you're at steady state, and those don't change. I mean, there's biologic and lab variation, but they don't change so much over time there. So steady state occurs when the peaks and the troughs don't change anymore. The time to steady state varies with the half-life, which I'll abbreviate with T and a little 1/2. It's independent of dose. And this is important. The time to steady state varies with the half-life, which is a function of the patient and the drug. It has nothing to do with the dose. The time to protection is determined by the dose and the frequency, the pharmacokinetics, and I should say, really importantly, the pharmacodynamics, or the PD. Next slide, please. So let's look at some contrasts in the next slide. And yeah, so it all popped up at once. That's okay. I had some animations here that won't work. So this is a similar graph. It's concentration, log concentration, and here I've specified log concentration of tenofovir diphosphate, the active form of the drug, or the log concentration of tenofovir diphosphate relative to the concentration of what it competes with in the cells, DATP, and Mackenzie will talk about that in her talk. And then I have PBMC mucosal cell and CD4 cell, because you could measure this in any of a number of locations. Some of these probably correlated better with efficacy. Others may correlate also, but not as directly perhaps. So in the red line, you have one dose that's given twice as often as the green line that's showing another dose. And if you look at the top, I've listed time to steady state in percent increments. And you see that both of these red and the green curves rise, and you're halfway to the final steady state concentrations after one half-life. You're 75% of the way there after 2 half-lives, and so on, till between 4 and 5 half-lives, you're 95% of the way to steady state. And that has nothing to do with the dose. The time to steady state is exactly the same for both of those. Now, if you move over to the right side of the figure, you have kind of in purple, female genital tract protective concentration. Let's say we know what this is in a specific matrix, in a certain anatomic location. And I've just drawn that line all the way across as a target. And then let's say we believe, because I think most of us would agree, that the GI protective concentration, protecting from receptive anal intercourse, is at a lower concentration. So I'm just putting these there as reference. Now if we go to the bottom, sort of along the time axis, now you can see where you intersect. Once the concentration in the red dose, and you see the red arrow coming up, that's the time to GI protection. And then if you slide along, you see if one was taking a lower dose, it's a much longer time to protection. Maybe if you were taking not daily but every other day dosing, the time to protection is quite different. And then if you slide over further, there's a red arrow, and this is time to protection for the female genital tract. Now, I haven't put any numbers on here. So the numbers and the magnitudes really are sort of irrelevant, but I think the relative differences here are generally agreed to. And then you also see, if at a sufficiently low dose, there's no time to protection in the female genital tract if you're not dosing enough. And I did that because I think the general belief is you got to be taking 6 or 7 doses out of a week to have adequate protection. So more frequent dosing gives higher concentration, but the same time to steady state. The time to steady state may, in the case of the female genital tract, or may not, in the case of the GI tract, equal time to protection. So time to protection varies with the site risk and with the dosing regimen. Next slide, please. So taking that, here on the right, you have a little bit more of the PK, and I listed just a few of the sites. We could actually measure drug in any of these colored boxes on the right. We could give it topically, you see in a sort of gold oval, or we could orally or topically, directly where it would be absorbed in the blood and then migrate to different tissues or back into the lumen in the GI tract or the female genital tract. But very importantly, the site of action is certainly CD4 cells at some location. And I'm going to suggest, for the sake of argument here, that we say it's tissue CD4 cells, because I want to be talking about data related to the pharmacokinetics in those cells. Now, if you look at the sort of concentration time curves, the little XY plot, in every one of those 6 boxes, the shapes are all different. And that's because the kinetics are different in every location. And we'll see just how different they are. Our goal really is to relate those concentrations in CD4 cells in tissue although we're not sure exactly which tissue. We're going to relate that to the pharmacodynamics or the concentration response to have some idea of the desired concentration. Next slide, please. So where is the site of action? Now, I don't have an answer, but I think there's some suggestion here. What you have in each of these figures, you have on the y-axis is relative risk reduction for all of the first generation of completed randomized controlled trials. These are unadjusted. These are not adjusted for adherence. This is just the raw relative risk reduction. And then on the x-axis, the unadjusted plasmid tenofovir in the figure on the left. But we know more than this. So we know that if you give a dose topically, you achieve that is vaginally or rectally, you achieve very much higher concentrations in tissue. So I have to make an adjustment for the gel arm in voice. Likewise, in iPrex, I know that the risk for transmission is much higher with receptive anal intercourse, but I also know that the tissue concentrations are much higher as well in the colon compared to the vagina. So I'm going to adjust both of those based on pharmacology and epidemiology, and then I get what looks like a much cleaner concentration response curve with variation, and you're actually able to generate some estimates, at least for sort of half maximal effect and a EC90 based on looking at all of these trials lumped together. So I think the fact that using tissue concentration as a frame of reference and adjusting that gives you a much cleaner concentration response suggests that some tissue very much related to colon tissue or vaginal tissue, if not in fact colon and vaginal tissue, is the site of action and certainly is very informative. Next slide, please. So here we have data on the left. This is from Pete's iPrex study, which many of you are certainly familiar with. This is data within the study that shows similar kind of data. The difference is that going down is good. And Pete in this paper, and I have no question at all about the interpretation of this, that Pete's identified here a inhibitory concentration 90%, right around 16 femtomole per million cells. And I'm contrasting that to the data I just showed you, where using a number of, you could measure diphosphate, you could measure a tissue-adjusted plasmid tenofovir the way I described, and both of these give you some idea about where you want to be in terms of target concentrations. Next slide, please. So what I've done here, the figure on the left, now we're addressing specifically the time to protection, having set up some of these preliminaries. And I'm just going to talk about these two studies. This will be all I talk about in the next 2 slides or so. On the left is HBTN 066. In this study, individuals took, under direct observation for 5 weeks, either daily Truvada, 4 doses a week, 2 doses a week, or 1 dose a week. We did this to understand what the concentrations of tenofovir diphosphate, which you see on the y-axis, what those concentrations are over time, over the 35 days of dosing, and then for a 2-week washout. And what you see here, I also put these red bars and marked iPrex IC90. So from the previous slide, I've taken those, and I've adjusted these a little bit because of some methodologic differences that we don't have time to get into. But what you see is, with the daily dosing, the iPrex IC90 concentrations are achieved in essentially everybody, but not until the first week. This is a very crude way of saying the time to protection, because these folks were protected at a high level, but the time to protection based on the iPrex IC90, which was a steady state IC90, daily dosing gets you into that range reliably. Not so much for the other doses. They're all below that. They're less frequent. Their concentrations, therefore, are lower. Now, the next study, so that's about a week to get into that protective range. The next study, the single-dose 14C TDF study, was done, a much smaller study. I'll give you details in a minute. But what we're looking at here is, that, again, the concentration of tenofovir diphosphate, but in multiple cell types and in multiple locations, not just in PBMCs, but in CD4 cells extracted from the total population of PBMCs to understand what the concentration of active drug is in the active site. So let's go ahead and move to the next slide to look at that data in more detail. So here, it was first of all, and this is very important, it was a very small study with 6 women. They got a single oral dose of TDF and a microdose of 14C TDF. We sampled blood, PBMCs, we did biopsies of the rectum, the vagina, in the same women, sort of back to back, so to speak, luminal fluid and blood at day 1, day 8, and day 15. There were more sampling on day 1. For the biopsies, we had day 1, day 8, and day 15. Then we assayed for tenofovir and tenofovir diphosphate. There's no FTC here. I don't have any data for FTC and CD4 cells, but I did want to be sure to show you the CD4 cell data for tenofovir and tenofovir diphosphate. So I'm just showing here concentration time, and you see the concentration falls over time. But with this data, we can directly estimate the rate of absorption, the rate of formation of the diphosphate, and the rate of decay of diphosphate in these specific cell types and in tissues. Next slide. So here we have the top table shows you the matrix. Now the matrices are anatomic locations, so peripheral blood mononuclear cells, colon, and female genital tract. Now, if I look at CD4 cells extracted from all PBMCs, or CD4 cells extracted from colon biopsies, or CD4 cells extracted from vaginal tissue biopsies, cells from those biopsies, you see 3 half-lives. PBMCs are 112 hours, the colon is 60 hours, and the female genital tract is 139 hours. And I have the lower and upper quartiles next to that. Right next to that, based on that, and what I showed you very early on, with that half-life, we can estimate a time to steady state. And if I do more complex simulations with more data, I get numbers that are very similar to this. The point estimates all fall in the same brackets. The time to 90% of a steady state, so I'm fudging a little bit. I'm coming down to around 3 to 4 half-lives, not 4 to 5, which most pharmacologists would do. The time to steady state is 16 days in PBMCs, in CD4 cells. In colon tissue, it's about 9 days. In a female genital tract, it's 20 days. Now, contrast those numbers to the unfractionated cells, and you see that for PBMCs, the half-life is shorter, as is the half-life in the female genital tract. So those estimates based on unfractionated PBMCs or female genital tract cells are much shorter in terms of time to steady state, time to 90% of steady state in days. The colon actually goes the other direction, but they're largely overlapping and not statistically significant. The other point I want to make here, which is sort of the primary data for why we made an adjustment to the IPREX before, which is at 24 hours, in the second table, the rectal tissue to vaginal tissue tenofovir concentration in tissue homogenate is 33.8 to 1. If I look at the same ratio of the active drug in tissue homogenate, it's 123-fold, or about 2.1 logs. But if I look in CD4 cells, it's right around 20-fold. So again, the cell type is important, and because it's different in the cells that are infected by the virus and the cells, therefore, in which the tenofovir diphosphate concentration is measured. So it's important to keep your eye on data from CD4 cells, or at least understand their relative differences compared to other cells that are more easily measured. And this data in the second table is very consistent with data from another study done actually before this, published before this, by Chris Patterson and Angela Kashuba, and I don't remember if Mackenzie was on that paper or not. But the data for not for the half-lives, because it wasn't published in the other one, but the ratios outside of CD4 cells are very consistent with that other study. So there is some consistency across studies and across methods. Next slide, please, and we're about done. So to summarize, the female genital tract, I think, requires protection 6, I would argue 7 doses per week out of 7 days, so almost all doses. Therefore, the time to protection must nearly equal the time to steady state. CD4 positive cells are the most relevant cells, even if our site of action is uncertain. CD4 cells, tenofovir diphosphate concentration, half-life is variable, anywhere from 139 in the female genital tract to 60 in the colon, and somewhat a little bit in between for the PBMCs. Therefore, my recommendations to the CDC had been in the past, and I've not made a recommendation to WHO, for female genital tract is around 3 weeks, PBMCs are sort of intermediate around 2 weeks, and the colon is around a week. And so I'll leave it at that. And next slide, we move on to Pete Anderson.
Great, Craig. Thank you so much. Incredibly helpful to set the stage. I know there are questions because a few have already come in, but I do think it's helpful if we get all three presentations, so including Pete and Mackenzie first, and then we'll open up to questions. Don't forget your questions, though, so feel free to write them down for yourself, or definitely email or use the chat function, as some of you already have begun to do. But with that, let me turn it over to Pete Anderson from the University of Colorado. And Pete, if you haven't already, *7 to unmute your line.
Okay. So can you hear me?
Beautiful. Yes, loud and clear.
Terrific. Okay, thanks much. If I could have the first slide, please. So I'm going to talk, and I've got about 4 or 5 slides, about a study we conducted in Colorado called Cell PrEP. And our goals in Cell PrEP were to focus on intracellular tenofovir diphosphate and FTC triphosphate, and to assess the accumulation that Craig had talked about at the beginning of his talk. So we really wanted to, measure this upswing of concentration, and we did the analyses in PBMCs, so systemic concentrations, and CD4 purified cells, which I actually didn't include in the presentation, but I'll refer to that, and rectal mononuclear cells. So these were mononuclear cells isolated from pinch biopsies, rectal pinch biopsies, as well as cervical brush cells. So unfortunately, harder to get cervical vaginal tissue, and so we elected to use brush cells, which are really epithelial in nature. Next slide, please. So this is the design of Cell PrEP. There were 40 volunteers. Half were HIV infected, half were HIV uninfected. We had wanted initially to balance by gender, but ended up with 13 women in the study. The figure shows when we collected samples, and we collected samples at the first dose, day 1, day 3, day 7, day 20, day 30. And again, this was daily dosing, and we assayed multiple PBMCs at each of those time points, so we had many PBMC data. And then each participant donated 1 rectal sample at one of the visits, so we had about 40 rectal samples. We staggered so that we got equal numbers of samples at each of those days. And then the same for women. They contributed 1 cervical brush sample at one of those visits, so you can already tell we had fewer data for the cervical brush samples. Next slide, please. So these are all the PBMC concentration time data. Tenofovir diphosphate on the left, FTC triphosphate on the right. The daily dosing, days of dosing are on the x-axis. We actually had a washout in the HIV negative participants, so you can see a washout phase after day 30. But I think you can visualize that by day 7, the PBMC concentrations are essentially at steady state. You can see the upswing in concentrations from the first dose until day 7 or so, and so we concluded that PBMCs essentially reached steady state by day 7 of dosing. And I didn't include in the presentation the CD4 purified cells. So we did purify CD4 cells from a blood draw at one time point per participant. And we saw essentially the same upswing in concentrations in the CD4 purified cells as we did in the unfractionated PBMCs. In fact, for FTC triphosphate in CD4 cells, the upswing was very rapid, and we saw that by day 3 or so, FTC triphosphate looked to be at steady state in CD4 purified cells. Those data, if anybody's interested, are in the supplement to the Seifert paper, which is referenced, I think, on the next slide. So we can go to the next slide, please. Yeah, there's the reference, and in the supplement to that paper are the CD4 purified results. These are the rectal mononuclear cell results for tenofovir diphosphate on the left, FTC triphosphate on the right. Concentrations on the y-axis are log. On the top of the graph, we converted back to the linear scale to give the concentration, so those are linear scale. I think what we saw here was the tenofovir diphosphate in the rectal mononuclear cells really mirrored PBMCs in terms of reaching the plateau or the highest concentrations by about a week of dosing. I thought it was interesting, FTC triphosphate appeared to reach steady state 2 hours into the first dose. So very rapidly for FTC triphosphate. Next slide, please. So these are the cervical brush cells, again, mainly epithelial cells. The left panel, on the top is tenofovir diphosphate, bottom FTC triphosphate. These two on the left are concentration per viable cells. So when we did the cervical brush sampling, we had to extract the cells off the brush, which left a lot of dead cells. And so the left panel, we only looked at drug concentrations in live cells or viable cells. On the right are the concentrations in the total number of cells, dead and alive. And you can see what appears to be potentially a more gradual upswing in concentrations. So you can see maybe reaching plateau what appears to be a bit later, more closer to 2 weeks. Now I put dashed boxes to represent the 95% confidence interval for the steady state concentrations, because I wanted to point out that we really had limited data here, and the cell type was not immune cells, not CD4 cells that Craig had mentioned earlier. So I think limitations, and I put the boxes to show that we saw concentrations consistent with steady state concentrations within the first week of dosing. So I wanted to point that out. Next slide, please. And I wanted to say a comment about the parent drug in cervical vaginal fluid, and I think one of the best studies that showed appearance of the parent drug in cervical vaginal fluids was Angela and Julie Dumond's study in 2007 that showed on the left FTC in CVF in the open box, tenofovir on the right, and the open box is first dose CVF concentrations, and then the filled square is steady state concentrations. And I think you can appreciate that both FTC and tenofovir appear rapidly after the first dose in CVF, and also don't appear to accumulate with multiple doses, which suggests reach steady state very rapidly as parent drug in CVF. Next slide, please. So in summary, from cell prep, we saw that tenofovir diphosphate, FTC triphosphate, reached steady state within a week, at about a week in PBMC, so systemically, as well as CD4 purified blood cells. We saw that when we had ample data, when we had 40 concentrations across 30 days of dosing, we could get a good sense of when rectal cell concentrations reached steady state, and that appeared to be about the same time about a week for tenofovir, and even quicker for FTC triphosphate. And unfortunately, I think our female genital tract data were less conclusive. I think we had fewer data. They were epithelial cells. But we did see that concentrations early in therapy at least overlapped with our steady state predictions. Okay, my last slide are some discussion points that I am a proponent that 7 days is enough for protection for men and women. And I think to support that, we see parent drug of both drugs rapidly appear in CVF. We see systemic drug concentrations reaching the steady state plateau by a week. That includes CD4 purified cells in our hands. Second bullet, I wanted to kind of broaden the discussion a little bit and think about the male genital tract, and in particular data in, for example, foreskin, where HIV infections take place. We have no data in that tissue that I know of. And I can envision PK similarities between female genital tract and potentially male foreskin, for example. And the reason I bring it up is I think everybody has been pretty comfortable with a shorter time to protection in MSM. And I think clinical studies trump PK studies and show high efficacy in MSM, including pharmacokinetic forgiveness in that population. And I would guess that some of that protection is coming from insertive exposures. And so, I think, we have to, think about those kinds of, PK, PD, relationships, and I think it's relevant to this conversation as well. And then my last point would be the macaque studies, so the preclinical studies, which have really guided this field, both PEP and PrEP, show high efficacy for vaginal exposures in that model, including PEP, which is effective even if started 36 hours after an exposure, at least for an HIV-2 model in macaques, and then the SHIV models from the CDC show high efficacy for event-driven dosing, so not even daily dosing for vaginal exposure. So I think altogether those help support, at least in my mind, a 7-day to protection recommendation. Okay, Mitch, that's all I've got.
Great, Pete. Thank you so much. And I'm really grateful to not only you for the presentation, but also a number of additional questions have come in. And really just want to, before I turn it over to Mackenzie and then get to the questions, just really highlight, what I think is hopefully clear to everybody is that we don't have some truth sitting out there. We have things we know, and as I said at the beginning, things we believe, and in public health we always try to balance those and making sure we are very explicit about what assumptions we're making, whether things are coming. I think, Pete, you said so nicely, there's only so much you can do with some of the modeling. Clinical trial data trumps that, and I swear I would never use that word. Clinical trial data jumps ahead of that, and I think it's really important to keep that in people's minds about what you're seeing unfolding here, or not only on this webinar, but in real clinical practice as well. But before we have more comments from anyone, myself included, in questions and discussion, I want to turn it over to Mackenzie Cottrell, who is at the University of North Carolina in Chapel Hill and has worked on a number of studies, including one that was presented, some of you may remember, back at R4P in Cape Town 2014. So Mackenzie, I'll turn it over to you.
Thanks, Mitchell. Can everybody hear me?
Yes, you are loud and clear.
Perfect. So the pharmacology study that I'm going to focus on today, like the cell PrEP study that Pete just reviewed focused on the active metabolites of PrEP, but unlike the cell PrEP study, we didn't give it a catchy name, so I don't have a name to explain it by. So before I dig into what we did with that study, I'd like to just review a little of the data, adherence data that came out from clinical trials to set the stage for why we did our study in the first place. So if I could have the next slide. So a lot of work has been done in the field to try to understand the relationship between adherence in clinical trials and how we measure adherence and the outcomes of the clinical trials. And Salim Karim has put out this beautiful correlation analysis that shows that there's a strong relationship across the outcomes of different clinical trials and when we measure adherence as the number or the percentage of participants who had detectable drug concentrations. But when we looked at these data, we thought that there was an important distinction to be made in the PrEP trial that both Craig and Pete have referred to, which was a study that was composed solely of men who have sex with men and transgender women. So if I could have the next slide. When we looked at men who have sex with men and transgender women of the PrEP trial, who remained uninfected over the course of the PrEP trial and had detectable drug concentrations, you can see that 49% of this subset had detectable drug concentrations. But when you pooled the numbers from both those who remained uninfected and those who became infected together and used that as a snapshot of what the overall adherence in the PrEP trial might have looked like, you can see that the number of men and transgender women in this study who had detectable drug concentrations may have been more consistent with the PrEP and VOICE trials, which were study populations of primarily heterosexual women. And an important note in thinking about these data is that the overall efficacy of the PrEP trial was 44%, whereas PrEP was found to be futile in the PrEP and VOICE trial. So this gave us some clue that the site that people were being exposed to HIV in may be an important predictor of how much adherence is needed for the drugs to actually work. And also, as discussed by both Craig and Pete, we seem to have a building body of evidence that says that we get higher concentrations in general in the lower gastrointestinal tract, where men who have sex with men are primarily at risk, when we compare that to the concentrations that we get in the female genital tract, where heterosexual women are primarily at risk. So that kind of gives you some background for why we did our study, and if I can have the next slide. So we took a four-pronged approach to this study. First, we wanted to determine what are the actual drug concentrations within an individual in both sites, so both the female genital tract and the lower gastrointestinal tract. And so we did this by conducting a phase 1 clinical trial where 48 healthy women were given a single dose of our PrEP drugs, tenofovir and emtricitabine, at various dosing levels. And then we sampled quite intensively blood concentrations, and we also sampled biopsies from the female genital tract and the lower gastrointestinal tract over 2 days after this single dose. And we quantified how much drug was in all of these samples. So next, we built a mathematical model that could predict drug concentrations in these different tissue sites across a population of PrEP users, across a simulated population of PrEP users. And we used this mathematical model to determine what the concentrations in these tissues would be if we had different dosing scenarios, so different scenarios of high or low adherence, or over the first 10 doses, and et cetera. So the third prong of this approach was to determine what kind of concentrations are we actually targeting. So I think, as indicated by Craig in his discussion of steady state versus efficacy, it's important to note that just because we see higher concentrations in the lower gastrointestinal tract doesn't necessarily mean that there would be more efficacy. If the concentrations that we're achieving in the female genital tract are sufficient for protection, then it doesn't matter that concentrations are higher in the lower gastrointestinal tract. So we wanted to know what kind of concentrations are we actually targeting to understand the clinical implications of the differences between the two spaces. And I'll flesh that out a little bit more in the next slide. But just for the fourth prong of the approach, we took our simulated population and what they were achieving in these different tissue sites, and we paired that with our target concentration, and we then made predictions about what proportion of that simulated population would be at or above what we were targeting given different dosing scenarios. So if I can have the next slide. So to unpack our target a little, I've created this cartoon which reviews how PrEP drugs work. So the cartoon illustrates the HIV DNA template and how the HIV enzyme, reverse transcriptase, builds HIV from this template. Now, if reverse transcriptase comes into contact with our drug, then it can't continue to build new HIV DNA, and so it can't infect human cells. But if it comes in contact with the DNA material that's in human cells, then it can continue to build new HIV DNA. So animal studies that were conducted early on showed that if we had a lot of HIV DNA material in the cell and very little drug, then the probability that the enzyme would come into contact with our drug over the DNA material was quite low, and this reduced our drug's ability to inhibit infection. So when we saw these data and thought about it, we thought that the best way to come up with a target would be to consider how much of this DNA material was also in the cell. And so our model looked at a ratio of the amount of drug that's in the cell versus the amount of DNA material. So the next piece of what we looked at when deciding what our target would be was the dose versus response, or concentration versus response relationship that Craig alluded to earlier on in the presentation. And this graph gives you a hypothetical concentration versus response relationship, where if you plot the effect of a drug over the concentration, you can see a nice sigmoidal relationship between the two factors. And when you then look at different points along this line, you can define what is the concentration that we would need for 50% effect of our drug, or 90% of our effect of our drug. And these are termed the EC50 and EC90 for effective concentration 90 or 50. And so to be more conservative with our model, we chose to target an EC90 concentration, or rather concentration ratio, because we're accounting for the amount of DNA material in the cell as well. And so that kind of tells you what our target was. So if I can have the next slide. So once we had our target established, we took our mathematical model that was predicting these concentrations in the tissues, and we looked at the proportion of the population that we're simulating that would be at our EC90 target in the lower female genital tract or in the rectal tissue over the first 10 doses that they took. And if you focus on our purple line, because that's when they take tenofovir and emtricitabine together, you see that by day 3, our model predicts that the maximal proportion of the population is at or above our target. So if I can have the next slide. So after defining the time to our protective target that our model would predict, we wanted to look at what kind of reduced frequency dosing would achieve protective or target concentration ratios in these two tissue types. And so we looked at if our simulated PrEP population took their dose 1 day a week versus 2 days a week up to 7 days a week, what would their ratios be and what proportion of them would be at or above our EC90 target? And so again, if we look at the purple, which is tenofovir and emtricitabine given together, you see in the female genital tract, if they take their dose 7 days a week, 100% of our population is at or above our target concentration. But if they only take 2 doses per week, that number drops down to 65%, which I think is pretty in line with data that's been discussed today and data coming out of clinical trials suggesting that women need a little bit higher adherence. But conversely, like what was seen in the iPrEP trial, in rectal tissue, if people took their dose at a level that was just 2 doses per week, 100% of our simulated population was at or above our target. So if I can have the next slide. I'll just quickly summarize that in our clinical trial, again, we saw that the concentrations achieved in the lower gastrointestinal tract are greater than the concentrations being achieved in the female genital tract. And our mathematical model was quite good at predicting what these concentrations were in both tissue sites. And so when we paired that mathematical model with our target, we found that by the 3rd dose, in both the female genital tract and the rectal tissue, our model was predicting that the target was being achieved in the maximal proportion of our simulated population. And when we looked at different levels of adherence, when our simulated population consistently took 7 doses per week, 100% achieved protection in both the lower gastrointestinal tract and the female genital tract. But when the population took 2 doses per week, while 100% in the lower gastrointestinal tract achieved our target, only 65% in the female genital tract achieved our target. And so when we looked at these numbers with the available clinical trial data, we felt that our model was reasonably in agreement with those clinical trial results. And so that sort of unpacks just one of the pharmacology studies that played into the decision to make a recommendation around how many doses per week might be required to protect somebody. And with that, I think that I'll give it back to Mitchell.
Great. Mackenzie, thank you so much. And again, thanks to you, Pete, and Craig for pulling this all together. And you can see now that nothing is easy unless everyone else understands everything and it's clear, but all really important to have this information out. A number of questions have come in on the line, both email and on the chat, and I think some people also have questions with hands raised and hopefully ready to open the line in just a moment. And I'll just quickly then, just logistically, if you do want to speak and ask your question on the line, you can unmute by pressing *7. Would ask you to put *6 after your question just to keep it clean on the line. And again, you have the other modes to do it. I will also say that while there are lots of questions and lots of different, as I think you heard from all 3 presenters, lots of different interpretations and beliefs, I would ask people to keep it relatively short. And given the time, we clearly are going to organize a call shortly after CROI, where we can have this conversation continue and certainly have more input from both WHO and CDC. One other logistics question a number of people have asked, will the slides be available after the webinar? and I'm not sure I actually asked the three presenters their permission, but our standard is to put them up, and I can talk to the presenters afterwards if there's anything you don't want up for publication purposes. But we will put the slides online very shortly after this call. So with that, I wonder if there are questions. If anyone wants to hit *7, and I will pause briefly to hear anybody. I would ask you to introduce yourself, and again, try to keep it brief so we can get to as many as possible. Any questions? One that did come up, and it came up, actually someone who wasn't able to join the webinar sent some questions in advance, and I think maybe something, Craig, you touched on, or maybe it was you, Pete, a question about PrEP. And I think one of you actually did mention the experience with PrEP. And I wonder if any of the three of you, from a pharmacologic perspective, or any clinicians, is there any observed difference of TDF-FTC, which is used for PrEP, for different transmission routes for HIV? So anything in PrEP that would signal a difference, as some might assume with PrEP? Any of the presenters want to? Oh, go ahead.
Sure. Yeah. So I looked a bit in literature if there were data on efficacy for PrEP in different populations, and I don't think those data are available, I don't, at least for TDF-FTC. I think there was some early data with AZT3TC showing some efficacy for PrEP, so I don't think the data are there.
Great, thanks, Pete. Any other comments on that?
This is David. Can you hear me?
Yes, go ahead.
Hey, David Evans. So I get that time to protection, see if I've got this right. Time to protection was based on a model that was daily pill taking. And I'm just wondering, as you look across the studies that I've reported so far, whether it was demonstration projects or the formal efficacy studies, it looks like a fair majority of people, I'm trying to distinguish. So for instance, with where rectal exposure is the primary source of possibility for infection, you wouldn't really need to worry about time to full protection because you're getting there anyway, whether it's 4 days or 7 days a week. But I wonder for women, for women whose primary exposure is the vagina, would days per week average adherence affect time to protection? So would they get there faster with 7 days per week versus 4 days per week, or does it not matter? It's really the most important thing is how many doses per week.
This is Craig. Can I reply?
Sure.
So I think it's highly relevant what the dose is in both situations. If, let's say, someone whose primary risk is receptive anal intercourse, the time to protection, if you take 4 doses a week, not 7, whatever the number is, if it's 4 days to protection or 5 days, it's twice that if you take half the dose, or if you take it half as often. The same is true for women. So it applies to both situations because it's proportional to the dose that you're taking. So it has an impact on both. In the iPrEP study where there was a double dose, that's a compensation to get there faster because the total number of doses will be less. And there's a lot of other complications about that study. But I think this is very important. I don't know if the others will disagree with this, but if you take half as much, it will take you twice as long to get to the protection. Whatever that time is, it'll be different if you're taking a different dose than the once a day that was prescribed.
Peter, Mackenzie, did either of you want to comment on that?
Yeah, actually, I can comment on that. We had run simulations with our model to look at over the first, 10 doses if somebody was only taking their dose 2 times a week, or if somebody was taking their dose 4 times a week, what proportion of the population would hit our efficacy target. And the proportion that hits the efficacy target is it increases at a slower rate when the simulated woman is not taking the dose every single day. So just from the modeling perspective, we saw what Craig is stating.
Great. Thanks, Mackenzie. A couple of questions came up that I wanted just to put out there and see if any of the three of you or others wanted to comment on. One, and I think, Greg, you talked about both, having mostly data around TDF, not FTC. And a question came in, is one of the two drugs, and I don't know, again, we've seen trials of tenofovir alone, but not FTC alone. Someone asked the question about which is offering the level more protection, and would that be different with different transmission routes?
This is Craig.
Go ahead.
I'll try to answer. So I think it's the most difficult part here is that if both drugs are relevant, or in fact, if both drugs are fine on their own, and the partners' PrEP study suggests that they were. There was a numeric difference in the point estimate. I think it was 67 versus 75. That was not statistically different, and in longer-term follow-up, that is not separated. So they appear, the benefit, I think the theoretical benefit is protection for resistance in the case that there's a resistant isolate to one of the two drugs, so it provides protection long-term. So if that's true, then based on what Pete showed and based on what Mackenzie showed, in the presence of FTC, protection occurs after the first dose. Now, that's what their data say. And maybe that's the right number. And if tenofovir is not adding anything in terms of immediate protection, well, it can add to immediate protection because it takes time to get there for tenofovir, where FTC doesn't. But it's possible that that's the right number, and the rest of the and the tenofovir delay, whether it's 1 week or 3 weeks, depending on the data you find most informative, may be irrelevant if FTC provides full protection. And Mackenzie's models and Pete's models, in terms of time 2 levels, both suggest that that's 1 day. So. Which is to add another wrinkle to all of this, maybe the recommendation is far less than anybody is recommending. I picked a long number, but I think that's probably very conservative because the other drug doesn't have very long half-lives. We don't know what the CD4 half-life is. I don't think anyone presented data here. I don't know that exists in clinical studies. But even if it was a similar proportion different from the data I showed, it might be 2 days is the time for protection, but it isn't a week and it isn't 3 weeks.
Craig, before others can come in, I want to just build on that and ask an additional question that came in the chat box because it may be quite relevant. Someone asked a great question about Mackenzie's, your data, seemingly echoing perhaps what was seen in FACS and voice. FACS being, for those who don't know, the tenofovir gel confirmatory study of Caprisa 04 and the voice study, and wondering if the inconsistent dosing results in far less vaginal protection than rectal protection, and maybe that underscores the need for higher emphasis on consistency and longer time to protection. But building on what you just said, Greg, because FACS was only tenofovir and voice, 2 of the arms were only tenofovir, might that be, so I guess 2 parts to you, Mackenzie, does your data kind of echo what we saw in FACS and voice, and how might one kind of compare, contrast, and conclude based on that in terms of consistency and time?
So, yes, I think consistency and time are important in the female genital tract. The distinction around FACS and voice that I want to be very cautious about, like thinking too much about my model versus that model is those were topical dosing, and topical dosing achieves much, much higher, very local concentrations of the active metabolites than oral dosing does. So my model was, based on data from oral dosing, so the concentrations were in the female genital tract were a lot lower than what the tenofovir gel concentrations would have been for Fax and the gel arms of voice. Now, I think that this gets confusing because it goes back to what Craig indicated at first. The exact site of infection isn't fully known at the current moment, and where we see those very high concentrations from tenofovir gel is in, biopsies from the female genital tract. But to my knowledge, no one's done work to see what the concentrations are in those local lymph nodes and whether we need the concentrations to be higher further back. So I don't know if I answered your question or if I just talked around it, but I would be hesitant to apply too much from my model to a topical dosing system.
Great. Thanks for that, Mackenzie. Let me pause and see if anyone wants to ask a question from the line. And again, *7 to unmute your line. Yes, please.
Hi, my name is Montika Levy. I'm the citywide PrEP coordinator here at San Francisco Department of Public Health. And I'm going to ask a question not just on behalf of myself, but on behalf of all of the folks on the line who are not scientists, myself included. And I think that many of us had hopes, tell me, certainly if it's not going to be able to happen on this call, but we had hopes of hearing a bit of consensus on what is the time to protection vaginally that, as our most conservative estimate, we should all feel confident conveying to our patients. So is that realistic for this call? I'd really love to hear, as a community hears about this conversation that's developed pretty quickly in the last couple of weeks, what should we be telling them?
Such a fabulous question. Let me stop and just hear if any of the three presenters want to say, and then I'm happy to hear what others say as well before I comment. So any of the three of you?
So I'll go first. This is Craig. If both drugs are important, I would say it's 3 weeks until both drugs are at protective concentrations in women whose primary risk is vaginal. It's probably true that it's more like 1 or 2 days because the FTC is perfectly fine. The one critical missing piece is the not having any CD4 kinetic data. If I had that, I could make a much stronger recommendation that it's 1 day. And I will add to that the fact that FTC is clearly active in ex vivo studies without the presence of tenofovir. Now, it's often the data I'm referring to is not published and is in combination with another drug, but I think FTC is probably good on its own, although I think that nobody gives it on its own, obviously. They give it in the combination. That's what's recommended. But I have high confidence at 3 weeks. It's possible that the Truvada is highly protective in the second day.
Pete or Mackenzie, care to weigh in?
Yeah, I'll weigh in. This is Pete. The supplement of the Seifert paper has FTC, triphosphate, and CD4 purified cells, and shows rapid attainment of steady state concentrations within the first week, as well as then tenofovir diphosphate and CD4 purified cells of blood. I think the one thing that we're missing is the multiple dose kinetics in vaginal tissue immune cells. And So things that we've heard today, I think, are single dose studies that are extrapolated, and that's what we have to do for. These are challenging studies to do. But in my opinion, is with blood coming to steady state at 7 days, and I think the good point that was raised earlier that FTC triphosphate is probably providing protection while we're waiting for tenofovir diphosphate to get to steady state. For those reasons, I think 7 days makes sense in my mind.
So before we even get to Mackenzie, I think to the question, I don't know that we have consensus on this line from the pharmacologists, let alone from implementers and agencies. But Mackenzie, did you want to add anything to that before we take other comments?
Well, I think in looking at my model, which had FTC and tenofovir in it, I agree that the 7 days is perhaps conservative but a good number, since we're not completely certain of the importance of FTC yet. Certainly in ex vivo cell culture, FTC works to protect the cells. I think it's important to have tenofovir in the PrEP regimen, given that there could be transmitted resistance in the population. It's another safety net. But I think I agree with what Craig said early on, that if FTC is important, it gets there quite quickly, and it gets there at concentrations that should be able to do the job. And so I think that the 7 days is a good number.
Mitchell?
Yes,
can you hear
go
me?
ahead. Yes, hey, Anna.
Hi, can I ask a question
Please.
sort of related to this? I'm just curious, and it's more a question elicited by the idea of what do we tell people in terms that are easily understood. I'm a little uncertain as to why we're not following the first do no harm principle, especially in the light of Mackenzie's data, which seem to underscore that the drugs are less forgiving for people who need vaginal protection than they are for people who need rectal protection, and that clearly I think we'd all agree some people are going to miss some doses sometimes. So if there's going to be missing of doses, it would seem to me as though we want to err on the side of caution and recommend 20 days for people who need vaginal protection, especially based on Craig's data. And I'm just wondering why in this case we're kind of stepping out on the ledge and saying, okay, maybe it's okay to say 7 days even though we're not sure, and there's strong evidence suggesting that it may take longer than that for women, especially if women are not taking the drug consistently. I would think that we would go with the CDC recommendation of 20 days until we have more sure knowledge of what puts people at risk.
Great, thanks, Anna. Any comments or replies to that?
Mitchell, it's Sheena here. I wondered.
Oh, go ahead, Sheena.
Hi, could I respond to that? I think, Anna, in some countries, Truvada alone is used as post-exposure prophylaxis, and it seems to work very well. And I think I worry that too long a time before, beforehand, that 20 days is raising too high a bar for some women. Not at the time they start, but if they've had a period of interruption and then they find themselves in a situation again when they need pre-exposure prophylaxis. 20 days is quite a long time potentially. And it doesn't really make sense when you take it in the context of post-exposure prophylaxis and how we use it. So I just wanted to make a comment that I'm a little bit nervous about the use of the word protection. And in clinic, I certainly prefer to say, likely to be highly effective. And then you can give people that shades of 7 days. If you want to be really conservative, 2 days, it's likely to be highly effective. And then I usually do say to people, let's face it, it does work if you take it after sex on its own.
Great.
Mitchell, can I make a suggestion? This is Bob Grant.
Please. Hey, Bob.
Hi. I think that if anything's clear from this last discussion, it's that we're not certain about what level of protection is achieved when. And we're hearing guesses and estimates based on reasonable pharmacology that range from 1 day, if emtricitabine is in fact protective on its own, up to 20 days. You could even argue for longer periods because the half-life in CD4 cells is such that it may take 28 days. So I think that one sort of clinical take-home point from this is that we don't really know with any precision. And I think that in situations like this, clinicians are well served by becoming curious about their particular patient that's sitting in front of them. Why is this an important question for them? And our answer, given the uncertainty, may differ depending on what's really driving the curiosity in a particular patient. For example, I just saw yesterday a couple, the serodiscordant couple, and they're protecting themselves with condoms, but they want to stop using condoms because she wants to be pregnant. And so their question was, how long, does she need to be on PrEP before they stop using condoms? And although I was an advocate for the 7-day message that WHO put out, I actually told them that 28 days was a reasonable time period. Let her stay on it a month. And that was driven, I think, by the fact that she wanted to get pregnant, but she was not in any hurry. It would be fine if they waited a month or two at least. And also a full month of PrEP use also gives her a chance to find out whether this is something that she's going to tolerate, whether it's something that she wants to stick with. But contrast that to another patient who comes in and says, I've got a big party planned for this Saturday, and I'm seeing him on Thursday, and he wants to know if there's any point in starting PrEP today versus just not doing it at all. And for that patient, I say, that first dose of PrEP is going to give you a substantial level of protection, and it only accumulates after that. And then I try to work with them to make a commitment to to start PrEP as soon as possible and to continue it for at least 28 days. I think that so I think in some ways being curious about what the question that's really being put on the table is important. The other thing is that when there's uncertainty in the medical literature, I think it's important to emphasize what we do know and what we don't know, and what's important. And I think that a lot of this discussion will tend to obscure the importance of good adherence to a PrEP regimen. And instead of spending a lot of time arguing with people about how long it takes to get to full protection, we might be better off focusing on ways to improve adherence and how adherence is feasible for people, but they have to be mindful and they have to link it with other events in their daily lives, and they have to be able to ask questions of their providers in a timely fashion so that if they have concerns or if they hear concerns from friends, they can have those addressed. Those, in fact, are major drivers of PrEP impact and efficacy, whereas, I think raising doubt about how quickly protection comes is only going to undermine people's focus on adherence and the importance of adherence and the importance of doing something to protect themselves. And if I can just have one last comment, I prefer not to think of recommendations in terms of conservative versus not, because what we think might be a conservative interpretation of this data may in fact be a counter-conservative recommendation practice. So for example, we may think that it's safer to recommend 20 doses before full protection is achieved, but in practice that might mean that women who would benefit from a week of PrEP choose not to use it at all. And so in our effort to do no harm and be conservative, we may end up doing harm. And so I think in the end, we're better off just focusing on what we know, what we don't know, and being very curious about what our patients are really asking.
Great, Bob, thank you so much. And I think you raised lots of important points, and we obviously are not going to reach either consensus or full conclusion on this call. And I know there are folks from Gilead and I hope CDC and WHO are still on the line, and you're welcome to weigh in. I do want to just ask a quick question that came in from a fabulous advocate in Malawi where the issues are quite real. And she's asking, is there a plan to derive additional data to, quote unquote, solve this uncertainty? And if it is uncertain, what more is actively being done to kind of fill in the blanks or fill in the gaps of our information? I don't know if any of the three pharmacologists or anyone on the line is aware of specific plans, not only to address the various recommendations as they currently exist, but the data, because I think one thing that's very clear is that we don't know, and there is not an answer, but rather lots of assumptions and interpretations. So is there a plan? And is anyone aware of additional data being collected?
Mitchell?
Yes.
I will take the bait. We just got approval for a surveillance study of PrEP seroconverters, and we can set it up so that people anywhere in the world can notify us that they have someone who's actually taking PrEP and who became HIV positive, and then we will work with them to try to identify reference labs who can do the resistance testing and the drug level testing that's needed to really understand whether the seroconversion occurred in the absence of protective concentrations of drugs or despite protective concentrations of drugs. So that study, information about that study is on a website that's called How to Offer PrEP. It's the word how and then the number 2 and then offerprep.org, and the study is called SeroPrep. And so I think that might be one way that we can do surveillance to see whether we in fact are seeing seroconversions in the presence of substantial levels of drug that would suggest that higher concentrations are in fact needed than were achieved.
Great. Thank you for that, Bob. Anyone else want to offer inputs about what else can and is being done in terms of data to inform what it is we know and don't know? I don't know if anyone from Gilead is still on the line, but I don't know if there's any additional data that you are collecting, and if this has become an issue as you've done the surveillance that's, I know, part of the monitoring that you do with respect to FDA and others. So anyone on the line from Gilead that want to take that on?
Mitchell, this is Mike. Can you hear me?
Yes, go ahead.
I would just comment. Thanks for this webinar. I would just comment that
just to be clear, this I can tell by the voice. This is Mike Cohn from UNC and the HPTN. This is not Mike Cohn from Gilead. Just to be clear.
Right. Well, not yet. So Mitchell, I do think the large double-blind, double-dummy studies comparing cabotegravir to TDF-FTC, the TDF-FTC has obviously monitored the concentrations, and so breakthrough infections in either arm will kind of further inform drug levels and breakthrough infections the way those studies are organized. OA3 has started, OA4 will start. So I do think there'll be more information about Truvada and breakthrough infections, kind of along the line Bob just discussed, but in the context of a clinical trial.
Great, thanks for that, Mike. I know that many of you, all of us, would want both consensus and clarity, and a number of people have put in the chat function, so what's the message coming out of this? And I don't think there is a message, and I'm not sure, and again, I'll pause if anyone from CDC or WHO wants to weigh in. It is very clear that this is a critically important issue, and perhaps should have been expected and anticipated in retrospect, with people aware of two different interpretations of this similar kinds of information coming out, reaching different conclusions, and wanting to be sure that there is, if not agreement and consensus, at least understanding of how those differences were arrived at. This is not the only experience where guidelines are different, and that there are umpteen examples in HIV and in medical practice generally. And we certainly are committed, and because of somewhat of the time issues here as well, WHO wasn't able to present today, but I believe are both committed, WHO and CDC, to take all of this on board and come back to us hopefully within a couple of weeks in a follow-up webinar and really try to help us understand how they're communicating it, and if they're not getting to consensus, why and how to communicate that. And again, I don't know if anyone, I think Dawn Smith was on. I don't know if, Dawn, you're still there and want to add anything?
Yeah, I'm here. Can you hear me?
Yes, go ahead.
Yeah, no. You know, CDC and WHO each have their own guidelines development processes, and we will, you know, as new literature comes out, we incorporate new findings into our processes. But, you know, the situations are very different. We have different audiences. We have different capacities for implementing various clinical procedures. And so it isn't surprising that sometimes our guidelines are slightly different. We really appreciate the opportunity to hear the new science and reconsider it. So thank you, Mitchell, for putting this together.
Well, it is a collective effort by the community, all keenly aware of the importance of getting to a point where we know what we're saying and how we're saying it, where we're and to whom we're saying it. So I think on behalf of the community at large, although I can't speak on behalf of the whole community, really keen. I don't know if anyone left. I know, Geneva, it's late, but anyone still on from WHO, but obviously very keen to hear from WHO directly. I'm not sure if anyone is on the line who can speak to that right now. Not sure if they, again, some scheduling challenges, but I know we will continue to push them, and they are committed to engaging with this information, and we'll come back on a webinar in a couple of weeks' time. I do think that there were some really important things, and just well, before I actually close it, I know we're now just at the bottom of the hour. Any other questions or comments that people want to get out on the table now? Obviously, lots to follow up on here.
Hello, could I just skip?
Oh, go ahead.
This is Brandon Gallagher. I was just wanting to ask, hopefully a quick question, even though I know there's not much in the way of data, actually not anything in the way of data, about transmasculine people who have testosterone-affected vaginal compartments, and whether or not you have any strong ideas based on what you do know about what time to protection for people with vaginal atrophy looks like.
Brandon, thank you so much. Any other pharmacologists want to take that on?
Great, this is Craig. I don't have an answer for you. I think it's a great question. Somebody ought to study that. We'd love to do that if the NIH wanted to pay for it. And what I will say is sort of the other issue is being looked at. We're over halfway done with a study looking at the two-way interaction with tenofovir emtricitabine and estradiol. I understand that's way off of your question, but that whole area and that the population of trans men, trans women that may be on hormones that clearly can modify tissue and therefore some of these variables that we don't really understand fully is a very important question. So I think this is so it's important. I wish I had an answer for you, and it's the sort of thing that'd be great if the NIH would fund that if somebody put in a nice proposal. If not Gilead.
Great. Thanks, Craig. And it's great. Brandon, I'm so glad you asked it. I mean, it's such a critical issue in an area of what we don't know. And I think to state the obvious, the more we know about oral PrEP over the last now 15 years reminds us how much we still don't know, whether that's about different populations or different issues of time to protection. So a research agenda is still needed across the board. Any other questions or comments?
Pamela Taxon, can you hear me?
Yes, go ahead.
Hi. Yes, I wanted to express as someone who's been training clinicians and non-clinicians for almost a year now that we do have concerns around the inconsistency with guidelines, and it's wonderful to have some level of consistency here with our CDC guidelines in the U.S., but it's very troubling for us, for those of us that are advocating for women, to see that there's a 2-week discrepancy between what we have for CDC guidelines here in our country versus the WHO guidelines. And so I just wanted to be sure and put that out there, that we are very concerned and troubled that there's such a variation and discrepancy between what we have here in the way of protection, vaginal protection information versus what we're seeing, for example, in the new HPTN study, in particular the video that's been put out into the public. And so for us, consistency in messaging and branding for the community at large is very critical to us, and we're continuing to be a little concerned about this discrepancy.
Yeah, thank you so much for raising it. I will say that it's not just obviously CDC and WHO. Even before the WHO guidelines were out, the Kenyan national guidelines had done a review and adopted 7 days. Unfortunately, it's actually quite late in Nairobi right now, and colleagues from the Kenyan guidelines process were not able to join this time slot, whereas the South African Clinicians Society several years ago had opted for the 20-day with the information known at the time. And I don't know if Linda Gale is still on. I know she was earlier but had other commitments. But there is a conversation now about reviewing those. And so it is not just what's happening with the U.S. normative guidelines and the global WHO, but also what's happening at the country level. And it's a very active space. I think it's, I would love for consensus and consistency as someone who is also not a scientist but focuses on communications and advocacy. That would make things far easier, and that is not always the case. And one only has to look at the treatment guidelines, which were different for several years until the 2016 WHO guidelines finally gave us clarity around the world about antiretroviral treatment being offered immediately upon diagnosis. So it is quite an evolving process, and one that we all need to be engaged with. The one other thing I just want to really flag and thank Craig and Pete and Mackenzie for is to really help us separate from the PrEP-specific questions to understand how the pharmacologic data can inform guidelines and what things we know and what things we believe and the difference between those two. And very specifically, I think this issue that we didn't really come back to, and I don't know if any of you want to make a comment, of what measurement matters most. And I think we have still a lot to understand about whether it is truly, if the actual point of contact in the vagina or the rectum is the driver, or is it a systemic issue? And so many huge questions there too, and how that gets monitored and tracked. So I apologize that we don't have really any new answers here, but hopefully a platform to have some conversations going forward about what needs to happen, and hope that we can schedule something within a couple of weeks, right, or the week after CROI, and get WHO and CDC to be on to really help us all understand where to from here. Any final comments from any of the three presenters pharmacologically, or anybody else on the line before we close? Oh, Michelle, are you on the line? Michelle Morehouse from South Africa? I don't know if you're still there. I just saw your hand up. You want to hit *7. Michelle, you there? So Michelle Morehouse, who actually is based in South Africa at the Vets Reproductive Health and HIV Institute, And, oh, she's trying to unmute. She's texting me. *7 on your line. Michelle? Oh. Basically raising the issue of epidemiology, and she has I didn't finish her introduction. She was also one of the lead writers on the Clinician Society guidelines, and this question of the epidemiology and the high prevalence setting. And I think I don't want to. Michelle, are you now unmuted? I can't tell. Oh, she's having trouble. Sorry, Michelle, but I raising the issue about from the South African side. I'm not sure if there's something more you want to type in since we can't hear you. I don't want to make words up for you. Very sorry, everyone, for this technical difficulty at the end. Okay. But basically, I think raising the issue of the challenge in a high prevalence setting, and I don't know if you were alluding at all to perhaps Bob's earlier comment about, and I think Anna's point about doing no harm is obviously the driving force, and I think that's really the question to be put to any of the agencies. How do we ensure we are doing no harm, and is it a question of ensuring PrEP access and helping people get on PrEP and focusing on the adherence issue, which I think we all agree for the long term is the essential one, particularly needing the consistent daily dosing for women and making sure that we are creating programs and guidelines that support programs that are able to do that. But again, not to debate that in the absence of WHO being here, but clearly the question to be put to them when we regroup in a couple of weeks. Sorry, Michelle, that you weren't able to unmute there, but I hope that conveyed it at least partially. Any other final comments from anyone? I am, there are some hands up. Hold on. Ken Mayer, are you still there? Or Steve Wakefield? I think both had hands raised. I'll go ahead and let you finish before we finish. Anyone else? *7? All right. Well, I realize it is now well past closing in on 100 minutes, and we have still hundreds of you on, and I'm just grateful for you to stay. Really grateful for the conversation. Again, apologies that this call will leave all of us hanging for what specifically to do next, other than to stay tuned for a registration link, hopefully very shortly, to ensure that we do a follow-up call the week after next to really talk about this as the next step. And really appreciate that. Also, we'll be sure to post the slides very shortly after the call. And I know Craig, Mackenzie, and Pete, and Angela, who wasn't on the call, are all have been very happy to take questions. And I am confident that if you want to continue to send questions to us at avac@avac.org, we will continue to compile those and work with Mackenzie, Angela, Pete, and Craig to be sure to get more information out or hand those questions off to others in other places if it's more a better place to answer some of those. So please do be in touch with us. And thank you all for sticking it out. And again, thank you so much, Craig, Pete, and Mackenzie, for opening up a really rich and complicated but important discussion.